Okay, so let's say square root of a. You can also write that as a to the 1/2 power. Cube root of a, you can write that as a to the 1/3 power. Same thing with fourth root. That's a to the 1/4 power. Fifth root is a to the 1/5 power, and it just keeps on going and going and going. So we have some nth root of a is a to the 1/n. Okay, so the reason that works is because if you think about, let's say, cube root of a. Okay, so we know that's any number that's multiplied to itself 3 times to give you a. So if we want to find a number that multiplies to itself 3 times, that's a to the 1/3 times a to the 1/3 times a to the 1/3. Or for your rules of exponents, as long as you have the same base, you just add all your exponents together. So it's a to the 1/3 plus 1/3 plus 1/3, which is a to the 3/3, which is equal to a, which is what we have there. So we know a to the 1/3 times 3 will give you a. A to the 1/4 times 4 will give you a. A to the 1/5 times 5 will give you a. So if you multiply to itself 5 times, you'll get a. All right, any questions on that one? All right. Okay, so we'll do a quick review of the rules of exponents. Okay, so remember your product rule, which is the one we just did up here. Oh, clean that up a little. Let's say if you have x to the power of m times x to the power of n. That's going to equal x to the m plus n. You just add your exponents together. Okay, now we have our power rule. Where if you have x to the power of m, and let's say you raise that entire thing to the power of n, then that's going to equal x to the m times n. Okay, so actually let me provide a little quick example of each one right next to it. So for example, for the product rule, if you have 3 to the 4th times 3 to the 7th, that's going to be 3 to the 4 plus 7, which is 3 to the 11th power. Okay, so for the power rule, I'll put it underneath it. Let's say you have, let's say x squared, and you're going to raise that to the 9th power. Then that's just going to equal x to the 2 times 9, which is x to the 18th power. So sometimes it's a little, bless you, it's a little easier to visualize it with actual numbers. Okay, so now if we have our quotient rule, or power of a product rule, we'll do that one next. Then we'll go to the quotient rule. So, bless you. Okay, so we have our power of a product rule, which means if you have, let's say, two numbers, x times y, raised to the power of n, then that's going to equal x to the power of n, y to the power of n. So basically, you kind of distribute the exponent to both. All right, so let's say, for example, you have 7x to the fourth power. Then that's going to equal 7 to the fourth power times x to the fourth power. And 7 to the fourth power is something, I don't know. All right. Now you have your quotient rule. Clean that up some. Okay. So your quotient rule just states, let's say if you have some x to the power of m divided by x to the power of n, then that's x to the m minus n. All right, so for example, say if you have, say 5 to the 30th power divided by 5 to the 23rd power. And that's just going to equal 5 to the 30th minus 23rd, which is 5 to the 7th power. Okay. Any questions so far? All right, I'll continue the rest on the next sheet. I'll wait a few seconds. All right. Look what I leave off. Quotient rule. Okay. Now you have the power of a quotient rule. Which pretty much state that if you have a fraction or a quotient, say x over y to the power of m, then just like with the product of a power rule, you just kind of distribute that to both. So it's x to the m minus y to the m. Okay. So for example, if you have, let's say 5 divided by x to the power of 3. Okay, and that's going to equal 5 to the third. Oh, clean that up some. Over x to the third, or 125 over x to the third. Okay, so we know that for exponents of 1 and 0, anything to the power of 1 is just that number. Nothing really changes. And anything to the power of 0 is equal to 1. Oh, that looks like a 6. There we go. Okay, so it doesn't matter what it is. If it's to the power of 0, it's going to be 1. So for this one, let's say, for example, 85 to the power of 1, that's just going to be 85. Nothing changes for that one. But if we have 2,345,575 to the power of 0, that's going to equal 1. Doesn't matter if it's raised to the power of 0, no matter how big it is, or even if it's just a variable. If you had y to the power of 0, it's still going to be 1. All right. And last are your negative exponents. Okay. If you have x to the power of negative n, that's going to equal 1 over x to the n. So if you have a negative exponent, you just move it to the denominator and make it positive. If you have a negative exponent in the denominator, you just move it to the numerator and make it positive. So if you have 1 over x to the negative n, that's just x to the n. Okay. So an example of this one would be if you had, say, 3 to the negative 4th power. That would be 1 over 3 to the positive 4. And if you had, let's say, 1 over 8 to the negative 2 power, then that just becomes, if it's a negative exponent here, you just move it up to the top. So you can say 8 squared over 1 if you want to, but you don't have to, which is just 8 squared. Oh, close that up. All right, so any questions on the exponents so far? All right. Oh yeah, can't forget that one. Okay. And another important rule that's going to come up over and over and over and over again. Let's say if the nth root of a equals a to the 1 over n, then the nth root of a raised to the nth power will equal a. So really the exponent and index, if they're the same, they cancel each other out. Okay, so to kind of show why that works, let's say the nth root of a, we know that's a to the 1 over n. So if we actually raise that to the nth power, a to the 1 over n times the nth power, remember using the power rule, that's a to 1 over n times n, which is just a, or a to the n over n, which is a. Okay, so if you had the square root of a squared, the 2's would cancel out and that would just be a. If you had the cube root to the 3rd power, the 3's would cancel out and it would just be a. So as long as the index and the exponent match, they'll always cancel out. Okay, so we'll do a few examples of this. All right. Okay, so for example, cube root of 8 to the third power would just be 8, because those two would cancel. Okay, so let's say if we had the cube root of negative 27 x to the third. Okay. Now with this one, you can actually rewrite it a different way. Remember, that's negative 27 x to the third to the 1/3 power. Okay. And remember, using the power of product rule, that 1/3 can go to both of those. So that's negative 27 to the 1/3 times x to the third to the 1/3. Okay, and when you add these two together, it becomes 1. Oh, that arrow kind of messed up the number there. Okay, so that actually gives us the cube root of negative 27. Let me go ahead and rewrite that. Remember, that's just the same as the cube root of negative 27. And this is just the same as saying the cube root of x to the third. Okay. Now the cube root of negative 27, remember that's negative 3 times negative 3 times negative 3 is negative 27. So this ends up being negative 3. And this one, remember your index and your exponent cancels out. So this ends up being just x. So you end up with just negative 3x. Okay. So whenever you have more than one factor as a radicand, sometimes you have to separate them and simplify each one. Okay, so let's kind of separate that. Okay, so let's say if you have, let's say the square root of y plus 4 squared. Okay, so whether it's inside or outside, the square and the square root still cancel out. But with this one, your answer would be y plus 4, but it would have to be positive. Because remember, whenever that index is even, what's under here has to be positive. Because you can rewrite this, because here if you square it, it's automatically going to be positive. But if you rewrite it like that, then that could be positive or negative, depending on what y is equal to. Okay, so that's why you need the absolute value around there. That means the radicand has to be positive. Actually, I should have pointed to the there we go. All right, so any questions on that one? All right. Okay, so this one kind of leads to the general rule that we'll go over once more, just because it kind of pops up here and there. X to the n to the 1 over n, or even x to the 1 over n to the nth power. When n is even, and x is greater than 0, must equal absolute value of x. Okay. So in other words, x to the power of n over 1 over n equals absolute value of x, or x to the power of 1 over n times n equals absolute value of x. Okay. So it doesn't matter which one is first. If you had, let's say, 4 here and 2 there, or let's say, 4 and 4 rather, instead of 2 and 2, it would still be the same. So if it's to the 1/2 squared or squared 1/2, still the same thing. Nope, bring that up some. All right, any questions on that one? Okay. So this is going to kind of lead into, I guess you could say, the main idea of this section. Okay, so let's say if we let the letters M and N represent integers. Remember, positive, -1, positive, -2, 0, and all those. Okay. So 1, say if you have x to the m over n power, that's going to equal, I guess you can separate it as x to the 1 over n times m, which is the same as the nth root of x raised to the m power. Okay. Now if you add a negative m over n, then remember that's going to go down to the denominator. So 1 over x to the m over n, which ends up being the exact same thing, but in the denominator. Okay. So we're going to apply that to some actual problems. All right, so what if we wanted to simplify? Say for problem A, say 32 to the 2/5 power. Say for problem B, 81 to the 3/4 power. And let's say for problem C, -64 to the 2/3 power. Okay, so for A, let's say 32 to the 2/5 power, you always get your numerator and take that to the outside. Okay, so that's going to be 32 to the 1/5 power squared. Okay, because you always want your exponent to be 1 over something. Okay, so remember that's just the, if you want to rewrite it, the 5th root of 32 squared. Okay. Any questions on that so far? All right. So remember, 2 times 2 times 2 times 2 times 2 is equal to 32. Okay. 32 equals 2 times 2 times 2 times 2 times 2. So the 5th root of 32 is just 2. So that becomes 2 squared, which is equal to 4. Okay, so 32 to the 2/5 power is just 4. All right, so we do the same thing for B. Say 81 to the 3/4 power. Okay, so you're going to grab the numerator of your exponent and pull that to the outside. So that's 81 to the 1/4 to the 3rd power. Because remember, by the power of product rule, if you just multiply those two together, you just end up right back there. Okay. Now remember, 81 to the 1/4 power is the same as saying the 4th root of 81 to the 3rd power. Okay. So we know 3 times 3 times 3 times 3 is 81. So 81 equals 3 times 3 times 3 times 3. Uh-oh. So I mean the 4th root of 81 is 3 to the 3rd power, which gives you 27. All right. Any questions so far? All right. Okay, so let's say for C, you have the negative 64 to the 2/3 power. Remember, you're going to get your exponent, your numerator, and you're going to bring that on the outside. So that's negative 64, and actually that 1/3, that negative's on the inside, so we need, bless you, negative 64 to the 1/3 power, and that numerator brought to the outside makes that whole thing squared. Or if you don't want to use 2 sets of parentheses, you can use a set of parentheses and a set of brackets. Kind of might make it a little easier to follow. Okay, so in here, remember that's just the cube root of negative 64. Which is perfectly okay as long as that index is odd. That can be negative as long as you have a 1, 3, 5, well, you can't have a 1, 3, 5, 7, so forth and so on. Okay, so we know that the cube root of 64 is 4, well, negative 4. Negative 4 times negative 4 times negative 4 is negative 64. So negative 64 equals negative 4 times negative 4 times negative 4. So that just simplifies to negative 4 squared.